Welcome back. So, in last lecture we discussed about a few important points about the active tectonics, and we also talked about the paleoseismology and what is the importance of seismicity, particularly the significance of seismicity in terms of the Indian subcontinent, as I told that we will discuss in detail when we are covering those topics. Now moving ahead, this was the last slide which where we stopped on the active tectonics, and mostly we were focusing on that the earthquake not kill, like usually earthquakes are not responsible for killing the people, but buildings, the damage which has been experienced during the ground shaking due to earthquake kills people. So, the construction part is extremely important, but the better construction can be done which can withstand the seismic shaking can be done only when we have the complete understanding of the paleoseismology, or at least we can say the earthquake process. But in this course, as I told that we will be covering on earthquake geology part. So, mainly we will be looking at that what are the signatures of such earthquakes on the earth surface as well as in the sediments. Now, further moving to this part, active tectonics data input, output and use to the society. So, the how this active tectonic part is important for, or it plays an important role for the society. So, there are few things which we can discuss in this, and the stepwise that what data we should collect and what are the inputs, the scientific inputs basically we do, and then what will be the output and how best we can do. So, overall exercise which we are talking here, as the title of this course itself says that it is towards the implications towards the seismic hazard assessment. So, it helps in the reducing the or minimizing the seismic hazard. So, scale of work, as we talked about that it is from the global scale we come to the regional scale to the local scale, similarly to that. So, we are coming to the regional and then local scale, we are coming down to the narrowing our studies and focusing our studies to a particular site of our interest. Okay. So, and now this depends upon that site of interest depends upon the urbanization. Okay. So, if you are going for urbanization or you are going for some industrial setup, then those sites are to be surveyed first before getting into the business of construction. Okay. So, data input is very important, and then finally, yes, of course, the output, and based on the output you can judge that whether the area is safe or not, and if not safe, then what best precautions or these remedies or the strategies you should plan to make the area relatively safer. Okay. Then, so the data input, whatever the data is available with us in terms of the active tectonics or the seismicity, and with the input of the scientific inputs, we have the outputs which are useful for the society. Okay. So, regional scale if you take, then what we do is the measurements and observation from topographic maps, then comes the aerial photos or field surveys and the geological maps. So, these are the inputs which you can put in terms of the active tectonics and the observations which you can make using the topographic maps, aerial photographs or satellite photographs or geological maps. So, basically we are talking here about the field techniques and all that. So, we will be coming to this part in coming few lectures. And then what are the existing geological maps that you can use, and the topographic maps usually will be helpful in talking about that what type of landscape you are looking at actually. Then based on that, the output will be that what that is the relative tectonic activity you can understand. Okay, areas where more detailed work might be productive. So you can identify certain areas, and that can be done based on the inputs which you have collected over here at the top, that is the measurements and observation of the topographic maps, from the topographic map, from satellite data or aerial photographs, and from the geological maps. So whatever the published information is available, you can input that, and the output can tell you that whether this area should be studied in further detail or not in terms of the relative tectonic activity. Then this input goes for the society, and that what I was talking about mainly for the regional planning. So you either you are coming up with some industrial area or residential area or a city you are planning, because now in India a lot of places we heard about, or and we keep on seeing on the news that we are going to have smart cities. Okay, and either the old cities are going to be converted to the smart cities, or the new sites will be identified where you are going to have the smart cities. So whether those smart cities are safe or not, but other than that, I would as a citizen of India, I would say that why not to look for or look at these cities, existing cities and towns and villages, okay, because they are also not so safe as we have been talking about. Okay. Then coming to the from the regional, we come down to the local scale, where we do more detailed studies, as we can we have pointed out here in the second one. So the based on the basic information which is available with us, we can take a decision whether we need more detailed studies in a particular area. Then we do chronology, measured tectonic deformation, and through measuring the tectonic deformation, geological and tectonic framework and all that. So this is basically the part of the methodology to some extent, but yes, of course we are going to cover in more detail about the field techniques as well as the methods which we are going to use to identify the earthquake features or not, and earthquake and associated earthquake related features and associated landforms. So basically here we are talking about the ages of the landforms, and then based on the ages or the dates, we can prepare the chronology of the tectonic events, and you can also measure the tectonic deformation, that then this can be done using the GPS, and also to some extent you can back calculate the tectonic deformation process using the chronology. Okay. So that you can talk about the slip rate, you can talk about the uplift rate, and so on. And also one can discuss about the geological and tectonic framework. This is on the on regional as well as on the local scale, that what is the implications of the geology and the tectonic framework, the structural framework of the region, on particularly on the active tectonic part. Then as I told that based on this chronology and measured tectonic deformation, one can talk about the rate of faulting, the recurrence interval, and the uplift rates. So one can discuss about this. So this you can do at the local scale, and further finally the site specific land use. Okay. So the ultimate interest of our interest is to look at the site specific conditions and basically the land use part. Okay. So if you have the information about the faulting rate and all that, then you can also talk about the magnitude. You can also discuss about that what will be the probability of experiencing an earthquake in near future, and that with the help of the magnitude and the geology. So based on that, you will be able to talk about that what will be the effect on this particular site, and based on that the structural engineers can go for the establishment, it's establishing the building codes. Okay, and the ultimate goal is the hazard reduction. So this is the ultimate goal of the whole exercise. Okay, so we want to reduce the hazard. We cannot. We are not saying here, or we are not claiming here, that we will completely make you safe from this hazard. No, it is not possible. Okay, we cannot stop earthquake. Earthquake is going to occur, and the processes which will trigger the earthquake are already on, and they will never stop. Okay, they may stop, but there is no answer right now with us. Okay, so the processes are on, and so earthquakes will occur definitely in future, and the best remedies which we are trying to do is that how to make our houses safe, how to make our people safe from this hazard. That is the ultimate goal of this whole study. So basically, to minimize the hazard and risk, okay, we need to understand the earthquake process. Now in this, the understanding earthquakes basically to efforts are towards reducing the hazard and risk. Okay, so what one can do is that for this, assessment of earthquake hazard at a particular site should be done very precisely, which includes identification of the tectonic framework. So you are talking about the regional scale. You are talking about on the regional scale what is the structural or tectonic framework. And then you are coming down to the geometry of the fault. So you are narrowing down your studies. You are coming down to the local scale, where we talk about the fault geometry, and thus what is the fault geometry and what types of different faults are there. I will talk in coming lectures, because these are extremely important aspect which will play an important role, that is geometry of the fault, when we are talking about the hazard. And then comes the septual pattern of the fault, how it behaves along the strike and its extent. Then we talk about the seismic source, how deep the earthquake is, okay, and the magnitude of the particular earthquake, and the recurrence finally. So these are few bullets which are, I would say, of course they are important, and for the assessment of earthquake hazard at a particular site. Nevertheless, along with this, you would say that why you are not talking about the geology part, okay, or we can say the lithology, geological language. Okay, we can say the lithology, that is we will talk about the site condition. So whether it is like the site is sitting on hard rock or on alluvium or alluvial terrain, this will play an important role, and this portion usually has been taken up by the geotechnical engineers. So along with this, what we are talking about, the tectonic framework, geometry of the fault, septual pattern of fault, seismic source. So some portion the geologists do, some portion has been done by seismologists, and then rest of the portion which we talk about, because we get into the building codes and all that, and what type of construction should be done. So geotechnical engineer along with the structural engineer. So this goes as a part of civil engineering, where people talk about the safe buildings and all that, the building codes, and what type of foundation one should have, and what type of building one should have, and depending on the geology of the region. Okay, that is the site condition. So the whole idea behind this exercise is, one is that what is the the seismic source, at what depth you will have an earthquake, and what is the surface manifestation of the fault, whether the fault is a normal fault. So, basically what we classify is, I'll come to that later, but we say normal fault, reverse fault, and the thrust faults or strike slip fault. So, here what we see is a normal fault, this block is going down anyway, but this is the expression of the fault on the surface, and this will be what we are talking about, the depth of an earthquake and the propagation of the seismic wave. So, energy has been released, the maximum energy has been released here. So, this portion, okay, which is sitting exactly on the above the focus of an earthquake, where the energy has been released, will have high ground acceleration. So, this is in the what we call epicentral area, but this location, that is, and any urban city or site of interest, is sitting far away from this one. Okay. So, the part which we will be interested in, that how far this city or any urban settlement is located. So, the distance will be a big question. Okay. How many kilometers? Okay. Because, for example, like we had in this earthquake of 2015 Nepal, magnitude was 7.8 or something like that. Okay. And it shook the areas up almost more than 300 kilometers. Now, again it depends on that, because the propagation of the seismic wave will not differentiate between any boundaries of countries or anything. Okay, no international boundaries. It will talk about, it will just move through the interior of Earth as well as on the surface of the Earth. Okay. So, local site condition is important, and this you will be able to understand when we are talking about the seismic waves. So, local site conditions are important. So, whatever we have been talked about in the previous slide, the most important part is that the source, the location of the fault, what is the amount of energy it will be released, because this is going to talk about the magnitude. Of course, another point important is the depth, at what depth this earthquake has occurred, and the local conditions, site conditions, okay, and how far we are sitting from the source. So, for this full understanding, what we need is, one is the tectonic framework we should understand. We should know the geometry and the subshell variability of the fault present in that particular area. Okay. Focal mechanism, that what I was talking about, that whether the faulting is a strike slip fault, normal fault, or reverse slip fault. This we will clear when we are talking about the different type of faults, but please remember this, and you can back refer this to understand what we discussed in the faulting pattern, because each type of faulting is having a different environment. Energy released, that is, earthquake occurs. So, at what depth the earthquake has occurred, that is important. Seismic wave radiation and propagation. So, depending on that, at which location your earthquake has occurred and from where the seismic waves are likely to be propagated towards your site of interest. Okay. And then the influence of local soil conditions, and this is important, may increase amplitude of seismic waves. So, as I was talking about, that the local site conditions either we are sitting on hard rock or alluvium, then these two sites are going to behave differently. So, this is important. And then earthquake hazard assessment by predictive modeling of earthquake ground motion. So, you can predict, of course, but not so precisely, but this prediction is mainly for the ground motion. Okay. So, one can predict that at a particular earthquake magnitude, this will be the ground motion which is expected in a particular area, and that will depend upon what we are talking about, the site conditions. And this you can predict and you can model. Okay. So, based on this, one can use this information for building code development and all that. Okay. Now, coming to the process part a little bit. So, usually what has been seen is that the earthquake is going to recur again and again. Okay. So, if you have a weak zone, so energy which has been stored, okay, that is the strain which has been stored within the rock bodies, will be released along the weak zones, and this is a very fundamental understanding. So, what are those weak zones? Those weak zones are fractures or faults along which the displacement will take place and the earthquake will occur, and the movement or the slip along the fault will occur during the process of earthquake, and then it will be seized, and then it will remain locked until it acquire or accumulate the strain until it releases during the next event. So, there is a cycle what we see, okay, but the stress again will affect the strength of the rock. So, this is what we have you will see that what we are trying to tell here. Okay. So, one is the local strength of the rock if it remains the same. So, over the time, what has been shown here, the point A, B and C and D corresponds to panel AD. Okay. So, this is your AD above, which shows the process of faulting and deformation over the time. So, you have the time here. So, this is your time and this is the stress which is you are applying. Okay. So, over the time it will build up the stresses, the building up, and this will be the point where it will release the energy. Okay. So, and then after that again it grows. Okay. And the time comes, it will release. So, this particularly what we talk about is the recurrence interval. Okay. So, these are the earthquakes which have been shown here. Okay. And over the time, so you have stress builds as tectonic forces deform. So, as I was talking about in one slide in the last lecture, that we have the plate motion is there and plates are colliding. So, that stress are building up along the collision zone or subduction zones or the transform fault zones. So, the tectonic force deforms rocks on either side of the locked fault. Okay. So, for example, if you see here, so suppose you are having the two blocks of the rocks and there is a weak zone. This is what I am showing here. So, to some extent it will be locked. Okay. If I am applying pressure here from both my hands, okay, then there is pressure is developing between this, but it is locked. But the time will come in the rocks, okay, it will slip. Now, this sudden slip is your event, and this is what has been shown here. So, you have the earthquakes here, and further the time the lag between these two, okay, or events is your recurrence interval. Now, the question is that whether this cycle remains the same over the time and if answer is yes, then we will always expect a similar magnitude earthquake at a particular recurrence interval. This is one thing. Okay. So, we will be able to predict very precisely that after so many years, I would say that precise means not exactly like Baba's, like we can say that this is then is ghadi bhukamp aayega. We cannot say that. Okay. But of course, we will be able to precisely tell that okay, after 200 years or 300 years or 400 years, the next earthquake will come. Okay. Provided what we understand here remains as it is. Okay. That the strain is developing here and released, strain is developing here over the time and released. So, this interval remains the same. So, we can say that these earthquakes which are occurring in a given time will have similar magnitude, because the stress which is applied and the strain which is getting accumulated is almost same to trigger the similar magnitude earthquake, but that never happens in nature, because the Earth is a dynamic planet and a complex planet. Okay. And complexity is in terms of also is in terms of the material of the crust. Okay. Crust is not homogeneous. So, and the any material you break will lose out the strength over the time. Okay. So, every time you keep on fracturing the same place, the strength will vary. So, this is what has been shown here. Okay. So, you have local strength of the rock. Okay. Then, so sometime you have a larger earthquake, the whole stress or the energy which was accumulated was released here, and then started accumulating, and the time when it came, okay, similar to this, it did not release the full complete energy or the stress which was accumulated. So, this what we call incomplete stress release. What does that mean? That over the time, the same time, okay, this one as well as this one, okay, the same amount of time has been taken, but the earthquake which was the energy which was released here was not the same here. Okay. This means that you may expect another earthquake in a very short time, and that is what has been shown here, that because of this incomplete release of the energy here, still this much was left out with it. And the just half of this was released, half of was left out. So, again just having in time span half of this. Okay. So, you are having what is been shown here, the half of this one, okay, was just taken up to trigger this event. Okay. And over the time, again, because the change in the stress from earthquake or near fault is changing, the change in the strength of the rock is going to be affected. Okay. So, we will stop here and we will continue in the next lecture. Thank you so much.